Okay, we are now looking at problems 11 through 20. Write the converse, inverse, and contrapositive. If a table has three legs, then it won't wobble. So if Q, then P. So the converse, if Q, then P. Whoops, my mistake. Sorry, if P, then Q. The converse, if Q, then P. All right, so if a table won't wobble, I'm going to need more space here. If a table won't wobble, then it has three legs. Is that correct? Yeah. Okay. Inverse, not P, then not Q. So remember our P was the table has three legs. It's our hypothesis. Our conclusion is that the table won't wobble. Okay, so not P. So if a table does not have three legs, then it will wobble. And then the contrapositive, that would be a combination of these two. That would be if not Q, then not P. So what we have for that would be if a table, let's see, what's Q? If a table wobbles, that's the negation of statement Q won't wobble. If it does wobble, then it doesn't have three legs. Okay, so that is number 11. Number 12. Give a counterexample for the following statement. If you like music, then you like jazz. I like music, so the hypothesis is true, but I don't like jazz. Easy enough. Not a fan of jazz. Whoops. So hypothesis is true. I do like music, but the conclusion is false. I don't like jazz. Write the following statement as a biconditional. A median is a segment with one endpoint at the vertex of a triangle and the other endpoint on the midpoint of the opposite side. Okay, so if a segment, no, sorry, a segment is a median if and only if, remember you can use this IFF, this means if and only if it has one endpoint at a vertex of a triangle and the other endpoint on the midpoint of the opposite side. Okay, so remember a biconditional is an if and only if statement. Both the statement forward and backwards is true. So if a segment has a midpoint at the vertex of a triangle, and then it's a median, or if a segment has an endpoint at the vertex of a triangle and then the other endpoint on the midpoint of the opposite side, then it is a median. If a segment is a median, then it has one endpoint at a vertex of a triangle and the other endpoint at the midpoint of the opposite side. So both statements are correct. The original statement and the converse of the statement, biconditional. So that's number 13. Number 14. Use the picture at the right for number 14 through 16. A is parallel to B and C is parallel to D. Identify two pairs of each corresponding angle. So corresponding angles have to be in the same place relative to the parallel lines. So let me focus on A and B here. So corresponding could be like angle 1 and angle 5. They're both in the upper left of the intersection. Alternate interior angles. So alternate interior angles have to be on the interior of the two, and they have to be on opposite sides of the transversal. So the interior could be 4, and then the opposite side of the transversal would be on the other line, on the other parallel line. So 4 and 6 could be angle 4 and 6. Oh, whoops. Consecutive interior, so once again these have to be in the interior of the two parallel lines, and they have to be on the same side of the transversal. So that could be like 4 and 5. So 4 and 5 are both on inside and they're on the same side of the transversal. So angle 4 and angle 5. And then let's see, we could also, alternate exterior angles. So these have to be on the exterior of the two parallel lines and they have to be alternate sides of the transversal. So that could be like angle 1 and angle 8. Okay, 1 and 8 are both outside of the two parallel lines. They're on opposite sides of the transversal. In this case, transversal is line D, so that would be angle 1 and angle 8. Of course, there's a lot of different angles you could have chosen here. There's a lot of different answers. 15. If the measure of angle 4 is 8x plus 3, measure of angle 10 is 12x minus 5, find the measure of angle 10. So 4 is right here. 10 is right here. Okay, so C and D are parallel lines. This is the transversal, which makes these alternate exterior angles, which means that they are congruent to each other. So angle 4 and angle D are congruent. So I'm just going to set them equal to each other. So let's see, number 5, 8x plus 3 is equal to 12x minus 15. All right, and then we just solve this. So 3 is equal to 4x minus 15. Whoops, did I make a mistake here? Minus 8x, 4x plus 15. No, I guess it is a decimal here. I always assume if I see a decimal that I've made a mistake, but I guess not. Divide by 4, divide by 4, x is going to be 4.5. We want the measure of angle 10, or sorry, yeah, angle 10, which was this one. This was angle 10. So we're just going to plug 4.5 into that. So 12 times 4.5 minus 15. Yeah, so that comes out to 39 degrees. Okay, number 16. Same idea. We just have to set up the equation and identify the relationship. Or sorry, identify the relationship, then set up the equation. Angle 3 and angle 8. Where is angle 8? Okay, so these are corresponding angles. They're both in the lower right of the intersection of the two parallel lines and it's transversal. So these are corresponding, which once again just means that they are equal to each other. So number 16, we got 24x minus 5 is equal to 9x plus 40. And what are we looking for? Angle 7? Oh, okay. Yeah, angle 7. So angle 7 is right here. So it forms a linear pair with angle 8, which means it's supplementary. So we're going to find angle 8 first, and then we're going to subtract from 180 to get the rest of it, to get the rest of the linear pair. All right, so let's take this. Okay, we'll solve this. Minus 9, so 15x minus 5 is equal to 40. Add 5. 15x is equal to 45. X is equal to 3. We plug that in for angle 8. So the measure of angle 8, if we plug that in, which one was angle 8 again? It was the 9x plus 40. So if we plug 3 into this, 9 times 3 plus 40, 27 plus 40 is 67. That's 67 degrees, which means that the measure of angle 7, that would be 180 minus 67, so 113 degrees. So angle 7, 113 degrees. Let's see, number 17, complete the proof. All right, we're trying to prove what? That the segments are congruent. We have a bisection, PQR. We have two angles congruent, PSQ and RSQ. Okay, so let's start. QS bisects PQR. So QS bisects PQR, that's given to us. PQS is congruent to RQS. That is also given to us. Oh wait, that's not the one that's given to us. Yeah, that's not the one that's given to us. PQS is congruent to RQS. Okay, so these are congruent because of the first statement, that QS is a bisector, that QS bisects PQR. So that is just the definition of a bisector. PSQ is congruent to RSQ. This one is given to us. SQ is equal to, or congruent to SQ, that's the reflexive property. Triangle, okay, so now that, so what do we have? We have, this is congruent, those are congruent, these angles are congruent. What was that? QP, what did they give us? PSQ, whoops, wrong angle. They give us PSQ is congruent to QSR, or PSQ and RSQ. Okay, so the two triangles are now congruent by angle side angle. Now that we have all of this stuff in our proof, we can say that triangle PSQ is congruent to triangle, so if that's PSQ, it'd be RSQ. And that is by angle side angle. And then now that you have the two triangles congruent, you can basically say that any angle or line segment is congruent to the corresponding part on the other triangle. So we want to say that the segments PS is congruent to the segment RS. So PS and RS, those are corresponding parts on the two different triangles. So we would say that that is CPCTC, corresponding parts of congruent triangles are congruent. All right, and that would be our proof for number 17. Number 18, also a proof. All right, so let's see. We're given the congruency of WX. I should mark these, WX and YZ. We're given the parallelness of WX segment and ZY. So these are congruent, they're also parallel. And that's given. Cool. Angle WXZ is congruent to YZX. Okay. So WXZ, that's this one, is congruent to YZX, that's this one. Okay, so because these two lines are parallel and this counts as a transversal, these are alternate interior angles. So alternate interior angles I guess we'd say the theorem, alternate interior angle theorem. XZ is congruent to XZ, so that is this one right here. XZ, so of course that is reflexive. Now we have enough information to say that the two triangles are congruent. So triangle PSQ is congruent to triangle RSQ. Sorry, wrong one. I'm looking at the wrong problem. Sorry, triangle, is this what we're trying to prove? Yeah, WXZ is congruent to triangle YZX. And that is, let's see, side, angle, side. It's by side, angle, side. Okay, good. Triangles are congruent. Side, angle, side. Number 19, position and label a triangle on the coordinate plane. Write isosceles triangle DEF with congruent sides DF and EF C units long. Okay, so we can make a right triangle very easily on the coordinate plane because a horizontal line and a vertical line will always be right. They're perpendicular. So this satisfies the right. We need it to be isosceles, so we can make these sides that are on the axes the same length. And it says DF and EF. So F has to be this point because they are, D is connecting to F and E is connecting to F. And they're supposed to be C units long. So this, if this is the origin, 0, 0, then this would be C0, and then this would be 0C. And then just connect these, and so this is now an isosceles triangle. This and this are congruent. It's a right triangle as well, and so this satisfies everything we're looking for number 19. Number 20, isosceles triangle RST with vertex angle S at A, 2B. Okay, so the vertex angle is the one at the top. All right, so it's gonna have to look like this. It's gonna have to look like this. The vertex angle is S at the top, and that's at A, 2B. Okay, so the vertex angle is always gonna be halfway between the two base angles. So, because so this is this is A units cross, and this is 2B units up. This is the origin, 0, 0. All right, so to get here, we would have to go A twice, so 2A, 0. And so that would be triangle RST. Okay, and that is 11 through 20.